So welcome to our last day of calculus for kids. Can you believe it? It's our last day already. Is that a good thing or a bad thing? This is fun stuff to do. I enjoy it. These are fun classes. Okay, so today we're going to talk a little bit more about slicing things up. It's kind of an extension of X-ray vision, how things are made or put together, integrals and differentials. And we've talked about how we can have slices of the same size, or we might make slices of different sizes. When we were doing flip books, and even when we were doing our mosaics, we can use different size pieces or same size pieces. Depends on what we're doing. And we've talked about big pieces and little pieces as well. So before we start with our Play-Doh, this is a fun activity to do. It just doesn't bode well for the computer. So parents, if you don't already have the Spark, feel free to do this one sometime today or this weekend. But I've got an apple here. Can you all see my apple? Can you tell me, how could I slice up my apple? How could I cut it up? Okay, I can't remember if you're Jamie or Lewis, so you have to tell me.
Lewis.
Okay, Lewis, which way would you
cut? You can cut the apple by using a knife.
Mm-hmm. Which way?
From my point of view, that way.
Like this? From the top down?
Yeah.
Okay.
You can see the inside.
And after I cut it in half, which way would you cut it again?
You would cut it that way?
Would you turn it that way and then cut it again, like this?
Yeah.
Okay. We would call those wedges, and we're cutting it from, this is the top of my apple. Kind of see the top of my apple there. But if I'm cutting it down like this, like if any of you have an apple slicer, your mom just whacks it and takes out the middle. So we're cutting, that would be called wedges. That's one way to cut an apple, and it's the way most of us usually cut an apple. What's another way to cut an apple?
Cutting it twice way.
We could do it that way. How would you do it, Violet?
Cut it in layers like this.
Okay, we could go in slices, and I could just go all the way across and make thin slices. We could do that too. Are there any other ways we could cut up our apple? Got any ideas, Lawrence? No? Crystal, got any ideas? We don't usually cut apples other than in wedges. We've talked about wedges, and we've talked about slicing it as we move across this way from the right. What would you do, Joe? How could we cut this apple that's not wedges, where you cut it in half and then in half and then those in half, and that's not slicing it this way?
We could slice it like that.
Like what?
Through the middle.
Through the middle like this?
So side that I see, he would be sliced off, and from the part that you see.
So like here? Oh, so this way, okay, you cut it in half and then work your way forward or work your way back and make slices. Okay, that would be a lot like slicing it this way, but in a slightly different plane. And Arjun had his hand up. Arjun, how would you slice the apple? Oh, you didn't have your hand up? Are there any other ways we can slice this apple? Or have we figured them all out?
Like, I guess you could do that. Like this.
If we slice it like this in wedges, yep, we talked about that one, but you weren't here yet. So that's one way. Lawrence?
I guess you could do it diagonally.
You could do it diagonally. There's nothing stopping us from cutting it like this and going along, is there? We could do diagonal cuts.
It wouldn't work as well, but
It wouldn't work as well. It might not be very fair, would it? Do you want this piece down here? Chook. While I get this piece up here, would that be fair? A way to share my apple? No? Has anyone ever cut an apple like this? In slices? In rings?
Hey, you want these ones?
You could, but would that be perfectly fair either? Not as fair, because this part's so much smaller. You'd get a little ring, and this part's fatter. You'd get a bigger ring. So we usually cut an apple in wedges because they're close to the same size, but we never even really think about that. Apples are this weird shape, and all the other ones aren't really totally fair ways to cut it up, but you can cut an apple that way. And you can see what shapes happen when you cut up apples or oranges or fruit. It's really interesting to see what patterns come out of it. Another weird way you could cut it if you wanted to take forever is you could get an apple peeler and you could go around and around and around and around and around and around. You could get it in like one big spirally ring maybe. So what's that got to do with math? Well, in calculus, if you don't have the apple in front of you and you're trying to tell me how to cut the apple, you got to have some words to tell me how to cut the apple, right? Can you say cut it that way? Will people know what that means? What if I say cut it top to bottom? How will they know which one's the top or which one's the bottom?
because of the stem.
Okay, so I could say cut it from the stem down. And then what would I tell them? If you don't have the apple in front of you and I want you to cut it exactly a certain way, going down like this, I could say start at the end with the stem and cut slices. What other words would I need to tell people so they'd cut it the way I want? Lawrence?
Left to right.
Okay, I can use left to right. Or if I'm going to go down, do I need to tell them how thick the slices should be?
You did. That's cool.
Yeah, I might want to tell them like 1/8 inch thick slices or something like that, all the way down.
What she's saying about slices.
What if I don't want them to cut on an angle? Remember, Lawrence said I could cut this way. I might have to use some words to tell people that you need to slice it perpendicular to the stem, or put it on the table and slice it exactly parallel to the table. And so all those words that you get in math, those are so people can figure out what you're doing without seeing what you're doing. Because they can't see your apple, we come up with these really precise math words to help us explain things to other people. And in calculus, they have a fancy term called with respect to, which tells us basically how we're slicing stuff up. Are we going around the circumference? Are we going from left to right? And so if there's any grown-ups that have calculus, that's what we're talking about today. Is the language of math really helps us to explain things. Now the other thing we already talked about is if I sliced up my apple like this, it's not very fair. Is there a way that I could make it fair and still slice it this way? So that everyone got the same amount of apple? What do you think, Violet?
Through the very middle.
Slice through the very middle? And then how will I know if everyone got the same amount of apple? What would I have to do? Could my slices be the same thickness? Could they all be 1/2 inch or 1/4 inch?
You could measure them.
I could measure them. If I cut my apple in half, I should just go get a knife and do it. If I cut my apple in half, this piece right here is going to be really big. And this one's going to be really little around or in circumference. So what can I do to make them fair? Jamie?
You can cut the big side a little over to the edge more, and the little side more in the after the middle point.
So what if I cut this one really, so like if I cut this one thick and up here I make it a skinnier cut? Is that kind of what you're talking about? Mm-hmm. That would be more fair. If you get the big piece, you get the skinnier one, and if you get the little circle, you get a fatter piece. Yeah. And we could, since we couldn't tell by measuring around it, how could we tell if I gave you the same amount of apple? Is there another tool in your mom's kitchen that maybe your mom has that could tell us if we had the same amount of apple? Since it's a different shape. What do you think, Lawrence?
My mom has a tool that cuts up apples too.
That would be nice. That will cut them up easily.
Wedges. Makes them in wedges.
Makes them. I have an apple cutter like that too. What can I use to find out if I gave you the same amount of apple? What if you're fighting with your brother and your mom says, look, it's the same amount of apple. If she measures around it, it won't sound the same because they have different sizes. I'm making you stretch your brains a teeny bit. What do you think, Joe?
You weigh it.
You could weigh it. Yes. So if I took a piece off and it weighed an ounce, then I could make sure that the other piece weighed an ounce. Because they could weigh the same amount and be different shapes, right? Yeah, they could. So with your Play-Doh, I want you to make any shape you want. It can be really simple or it can be really strange. And then we're going to play a little bit of a game with it with someone at your house. So hopefully you have, if you don't have a sibling, you have a grown-up nearby who can help you. And you can do it on your own. It's just not quite the same. But Lawrence, if you're the only one there, it's still just fine. You can do it on your own.
Did you make an apple shape? Is that what that is?
I'm trying. I was trying to.
You want to make it? You do it?
So make whatever you want.
No, I think this is good.
Oh, yes.
Got your shapes though, Joe? Lawrence is getting one. Violet's working on hers. Doesn't have to be fancy. Doesn't even have to be anything in particular.
Make more. I'm gonna make this time a golden apple.
Nice.
Okay.
With a.
You ready? I just have a sphere. We call these circles a lot, but it's a sphere. Because it's 3D, and it's not a perfect sphere by any means. It's kind of lumpy and bumpy. Okay. Ready for instructions?
Reasonable.
No. Okay. Player number 1 is going to slice a piece off of this shape. Whatever piece you want to slice off. And the job of player number 2, generally the grown-up in the room, is to slice one off that's the same amount of Play-Doh. Might not be the same shape, but the same amount of Play-Doh. So how are we going to know if we got the same amount of Play-Doh cut off of our shape? What's a quick way that we can tell?
The same amount of Play-Doh.
Any ideas? After you each cut off a piece of Play-Doh, how we can know if it's the same amount? We could weigh it like we talked about with the apple, or you can do what Lawrence is doing. You can smush it up, roll them into a ball, and see which one is bigger. Because Play-Doh we can smush. So that's why Play-Doh is really nice. So take a piece and cut it off, player number 1, whoever's number 1. And then the next person's job is to cut the same amount of Play-Doh off right next to it and see if you can get the same amount of Play-Doh, especially as the shape's changing. So circles are actually kind of a fun challenge to try. Did the instructions make sense? Okay, I'm gonna let you try that with the people around you until you completely cut up your shape, and we'll see what happens.
Well, let me see it. So you know how much.
Well, just
Just put it down. So I can see.
it's my turn again.
Okay. Don't do that to the scale. Honey. Just set it gently on the scale. 17.
1 point. It was 1.7.
No, 17. 17.0.
7.
It's 12.5. Too small again.
Let's roll it into a ball. Put it next to each other.
Okay, I'm gonna cut off the first one. This time. Close.
My turn.
It's 5.4.
5.8.
5.8.
I'm a little bit bigger.
Yeah, but you're definitely close.
Yeah, you're the closest.
Let's do it again.
Oh, I see the Warners are going for the scale. They want to know exactly if it's right, huh? Lawrence, is your brother doing a pretty good job, or are you tricking him?
It's about the same kind of.
Are you getting him about the same? That's good.
Okay, Lawrence, another. Lawrence.
They cut off half of the quarter.
Can you see your amount?
And somehow it's still just as big.
Can you see your amount?
Cassie, do you need me to
Yeah.
I think there's something satisfying about cutting Play-Doh because I see lots of smiles. It's a fun activity. Those are some cool shapes. So Lewis and Jamie, do you want to tell me what happened at your house when you tried this activity? How did it go? Hang on, let me turn your microphone on. Okay.
It was kind of tricky. Well, we had to keep like slicing little bits of the Play-Doh off to equal slices.
So it was hard to get equal slices right at the beginning? Yes, it can be, especially if you make tricky pieces. It's harder than it sounds, isn't it? Thank you. Violet? Share what happened at your house?
Make chocolate.
Oh, you're muted. There we go.
I have a question. When will we use the fruit?
Who what?
When are you going to use the fruits?
Oh, you'll use the fruits with your mom and dad after class because at the computer, it's kind of messy and not everyone's able to cut them at the table. So kind of what we talked about before, you can come up with all kinds of fun ways to slice your fruits and see the patterns, but when we're done with our class.
Just like
So if you want to do it right now with your mom and dad, you're welcome to. We just aren't doing it in the class because it's kind of hard to put a computer where you can work on the fruit. Not everyone can do that. Yes, you can eat the apple. Was it tricky or hard to get the equal size shapes? Did anybody else find it kind of tricky, or did you have a really easy shape that made it really easy? Lawrence?
Some of them were kind of easy, some of them were kind of hard.
Which ones were easy?
Circles.
Circles weren't so bad? Okay. Which ones were hard?
Well, there's one shape that I made. I'll try to make it again.
Uh-huh.
It takes a second to make it.
Okay. When you have it, hold it up.
Well,
Does anyone else want to tell what their experience was like, how it went at your house trying to do this? Okay, Joe, go ahead.
Well, mine was pretty easy because I kept making apples of different colors. Like, for example, this one. It's green, but it has a golden stem. And I also made a golden one
we also did
With-
a heart, huh?
with an orange stem.
And what is that one going to be?
Did you slice them up,
No fruit. That's right.
or did you just have fun making them?
No, we did slice them up, and then we
Put some.
smushed them to see if they were the same.
Ah. Was it harder to get the same size than you thought, or was it pretty easy?
Yeah, it was pretty easy.
It was pretty easy. They look pretty close. I know Violet weighed hers. And sometimes it's hard to tell without weighing if you got exact.
It-
It matters, but Arjun, how'd it go at your house?
The sizes are quite same now. This is the circle.
Are they about the same? What shape did you start with?
We started with a big circle, but then it got different. We just then made them, and when we did more shapes, every shape we did, at first we weighed them and then we made them into circles to see how big they are.
Very good. Some shapes are easier to tell if we're getting the same amount, and some shapes are very difficult, isn't it? So if we're doing like a square, it's a lot easier to cut off slices that are the same size. Even some circles or a big, long, like a hot dog shape. But if you have a really weird shape that you need to slice up evenly, it's really hard to know because we can't really tell with our eye, and we can't necessarily slice it up for real. So that's, again, where calculus comes in handy, is in helping us do things with these weird, uneven, irregular, curvy shapes. Because we can do things that we can't do with other kinds of math. Very cool. Play-Doh is highly addictive to just smush. Okay, who's ready for another Play-Doh challenge?
Shelly
Play
and
challenge. Hi, Zahabia. You guys just got here.
We actually got dropped off. We had computer issues.
Oh, no. Okay, I'll fill you in at the end on what we did do, and the spark will be coming too. So do you have any Play-Doh or clay? Okay. We're going to move on to another activity. So who has their clay ready? We're going to, I want you to take your clay and I want you to make a sphere like this. 3 different ways. But the way I made it, smushing it all together, that's not allowed. They want you to make it out of pieces because this is calculus. So you have to build a sphere out of some kind of pieces. So you can't just mush your Play-Doh like mine. And I need you to do 3 different kinds of pieces. What do you think? Can you do it? Think about all the things we've done this week and the different ways we've made stuff when we were modeling and slicing and cutting things apart today. And think of 3 different ways that you can make a sphere out of Play-Doh without just making one big block. Okay? This one might take you a little while. So, and if you need help from the grown-up in your house, you can ask them, and if you really get stumped, we'll hold each other's up and might get an idea from someone else. Okay? Crystal?
Circle, ball.
You have a question, Crystal?
I have a question.
Uh-huh.
Clarify the instruction. Is it you use 3 different pieces or do it 3 different ways?
3 different ways. You'll end up with 3 different spheres that are all made a different way. Yeah, thank you for asking. You can either make one, mush it, make another one, and mush it if you don't have a lot of Play-Doh, or it's helpful if you can make all 3 and compare the 3 to one another. But if you don't, there will be enough variety from the other group. We can still compare each other's. So if you can't come up with 3, it's okay. Someone else will come up with something different. So how can we build a sphere without just mushing our Play-Doh into a sphere? What do you got, Lawrence? Starting to wrap.
It's kind of a sphere.
How did you start to form it?
I did this. I tore up a piece. Then I made it so it was like this. And I got another one of those and put it here.
So you're kind of like making layers like you do with paper mache of flat pieces that are slightly curved. That's a new one I've never seen before. Very creative. Can you come up with some more? And they may not look super duper spherical, but see what you can come up with. Think about parts and pieces, because parts is a lot about calculus. Slices and parts. Arjun, you got one? Here, give me. What?
It's really math.
Yes, it's really math. Whenever we make a part out of a part, or make something bigger out of small pieces, we can call it calculus.
Yeah, I've got an idea from our face.
From your face yesterday? That.
Yeah.
Oh, good.
This time I did rectangle.
A rectangle.
Yeah, and then I kept adding them and adding them.
I am so glad you had that by you to inspire you with a good idea. All right, Lawrence.
I kind of made another one.
Out of a different method, or you made your sphere with overlapping?
Huh?
Is that the overlapping pieces?
I don't think that they're overlapping.
How did you make it?
Do you want to hold it up?
This is how I made it. I like made a hole in one
Uh-huh.
like this, and then did the same thing with another piece, and then put them together.
Ah, kind of like those plastic Easter eggs.
Yeah.
Very creative. So you cut it in half and it's hollow, and you've created a sphere, a hollow sphere. Good job. Like how you think. All right, Lewis, what you got?
So I got 3 pieces.
Uh-huh.
3 pieces. There. And then there.
Ah, you got some slices. Good job. You can use slices to build a sphere too.
Mm-hmm.
That's kind of the tricky way, especially if you're trying to use a lot of slices. It gets harder and harder, doesn't it?
Mm-hmm.
And if you don't make a sphere and cut it up first, if you actually try to just build it from the Play-Doh without having the sphere already made, then that's really hard to try to create the pieces. There's a really good Spark you'll get that's called How Would a 3D Printer Do It? So good job. Does anybody come up with another way that you can build a sphere out of Play-Doh? We've seen 3 of them. You want to show one, Arjun? I see it. You want to tell us about it?
So I kept making rectangles out of clay, and then I rounded them, and then I filled them up.
So you took little pieces that were rectangles and rounded them to put it in and form your shape? Is that kind of what you did?
Yeah.
Good job. Very creative. So it's kind of like a 3D mosaic or something, huh? I like it. Good job. Can you think of another way? Not right now. Keep thinking. You can use someone else's way too. All right, Crystal.
So we did the backwards of slicing, I guess. We made the slices and then rolled them up like this, and then we spiraled it.
Oh.
That would be like basically a circle, and then we mushed them together.
So you made a bunch of circles by spiraling and then mushed it together. Cool.
It didn't quite turn out spherical because the middle has to be fatter, but
Tricky, huh? Very good. Very good. It's fun to just see what kinds of ways we can come up with to do it. Okay, Lawrence. Get another one?
Yeah.
Okay, let me make your picture bigger. How'd you make this one?
I took a piece and rolled it up like this,
Uh-huh. So made a snake.
and then turned it around and kept doing that until it was this.
Ah, so very similar, a little bit different, but similar to what Crystal did. So you did slices, but slices that were made out of one line turned into a circle. Good job. Kind of a two-part thing that you and Crystal both did. Tricky one. Joe, you got one to show? Okay, go ahead.
Cool. So how many have you made so far?
Oh, you're muted.
Has anyone done
You're still muted.
Well, I thought like maybe make small parts and seal them together.
Uh-huh.
Small parts of the surface, but then I was thinking maybe use some like bricks
Mm-hmm.
from what my mom was doing, because she was making little block pixels, but thought maybe I can do it like I was building up bricks.
What, do you have it? Can you hold it up? Cool.
I did it with Mosso Red.
So we've got pieces that came together kind of like blocks or bricks, huh?
You can see like maybe a crack from it.
Uh-huh.
And the purple right here that I'm closing in on.
So you have some cracks and spaces.
This is mostly when I was sealing up, and red, some of it is when I was sealing up too.
Very good. Very creative way to do it.
You want to show this?
Joe. Oh, and then so your slices.
My mom's slices.
Your mom's slices, that's similar to what Lewis was doing. Those are really hard to do, aren't they? You think, oh, how hard can it be to make a circle? But it's really hard to make a circle, or a sphere, I should say. Good job.
I'm done.
You're done? You want to show it, Jamie?
Uh-huh.
Okay, what have you got?
I used 4 balls to create one gigantic ball.
Wow, so you used 4 balls and put them together?
Uh-huh.
Did you mush them all together after that?
Uh-huh.
Uh-huh. You can make a circle, a sphere out of spheres. I like to do that one too. I started to do it. There's mine. Looks kind of like a grape, bunch of grapes when you do that.
Yeah, a bunch of grapes. Yeah.
So we can do small circles. We can make squares out of squares and triangles out of triangles and circles out of circles. Good. And I think I saw Zahavia's hand. Did I see your hand, Zahavia? Okay. Do you want to go?
Well, I cut it with my knife 3 triangles out of this bed, and then I made a pinch pot and connected it to the top.
I don't know if I've ever seen anyone in all these classes do it like that. That's really cool. You know, in fact, Miss Maria, who is the one in charge of all of natural math, is going to have so much fun watching this recording, and she's going to be so sad she wasn't here because you guys have discovered more ways to make circles than I've ever seen in one of my calculus classes. That is so cool. Good job.
Thank you.
You're welcome. All right, Arjun, what you got?
So, I got players.
Uh-huh.
Big.
I can't.
Do you want me to make you big?
Yeah.
There you go.
So I got layers,
Mm-hmm.
and then I stick them together,
Mm-hmm.
and then I kind of flattened it.
And then you shaped the outside.
Yeah.
Good job. It kind of bugs our eyes when it's not nice and smooth, doesn't it? So you came up with 2 different ways so far. Good job. And I think we've had, like,
My mom made the other one.
your mom made one? What'd your mom do? Oh, hers is a small circle made of, a sphere made of spheres.
Did you like this one?
Yes.
Good job. Oh, Joe, let's see that one.
This is my mom's again, and it's supposed to be like an orange middle.
Yeah, it's made out of wedges.
Mm-hmm.
And it makes a sphere. That one seems like it's almost easier because we're so familiar with circles made that way. It looks very spherical. Thanks for showing that one. Anybody have any other ideas of how you can make a sphere or anything you've already done, even if it's the same as everyone else's, doesn't matter. Did you want to show something else, Arjun? No? Okay. You guys did such a great job. So much fun. All right. We still have a little bit of time, but I don't have another activity, so I'm going to ask you guys a question. Oh, go ahead, Lawrence.
I made the same thing that Joe's mom made.
You did it. Oh, you have a lot of wedges in there. Good job. So I have a question for you guys.
Waffy cat.
What was your favorite activity this week?
This.
This?
This.
Play-Doh's really fun.
This.
You
My
like
favorite
Play-Doh?
was making flip books.
Flip books? Flip books? Crystal, what's your favorite? Oh, here, let me turn on your mic.
What's your favorite?
Okay.
Get louder.
Making flip books.
You like the flip books? That was fun. Arjun, what was your favorite?
Flip book.
Flip books? Sahabia, how about you? Oh. Okay, say it again. Oh, darn. There we go.
This.
This was fun and your favorite? Oh, good. Violet, what was your favorite thing this week? Oh, there, let me turn on your mic. There you go. Say it again. What? Today with the Play-Doh and the slicing?
Yeah.
Yeah. It's just something about Play-Doh that's really fun to play with, huh? And it's fun to play as a game and see all the different shapes and weigh it out. Now you can play with fruits and vegetables in your kitchen. Maybe you can make a fruit salad or a vegetable salad for dinner, and you can try slicing things in different ways and see what happens. A great question is, I wonder why that happened. That can lead to all kinds of different discussions. Or what would be the most fair way to cut this fruit up so everyone gets the same amount? Now that you've sliced up Play-Doh, can you slice an apple and make it fair? Can you slice a cantaloupe and make it fair? Can you slice up star fruit or an onion? What about a cabbage? All kinds of crazy shapes. Don't poke your eye out. Okay, are there any questions that you have for me? No? Well, guess what you're going to get by email. We've done 5 activities this week, and there are 11 sparks from calculus that have been created. So there's some other activities that you can try with your parents or friends that build on the same 3 principles of calculus. You'll start to recognize that calculus is a lot about putting things in parts and putting the parts back together. It deals a lot with curves. There's some topographical maps. How would a 3D printer make it? But hopefully, grown-ups, you'll recognize that I've just followed the sparks. We use the starting activity, we get going, we explore, we remix, and a great question is always just tell me what you did. Tell me what you were thinking, or what do you notice? And be on the lookout for patterns that will help you to have a good conversation. And even though I completely relate to that feeling of like, where's the math? Because I haven't done the formal calculus math. Your kids don't really want the equations anyway. And they're not ready to go to that point at this point anyway. So it's like an investment in their calculus thinking and their calculus eyes that will pay off when you pay the calculus teacher to teach your children calculus. So that's my little spiel for the mom and dad that are listening in the background. So thank you, all of you, for being here and for being such a fun class. I'm so excited to show this one to Maria because I think she's going to be blown away by how you guys made your spheres. You guys are so creative. Yes?
Sorry if you don't mind, since we missed the first half. Give us a quick review of what it was.
Yes, what we did, Zahabia, is you take your Play-Doh and you make any shape that you want, so you can make it into anything at all. And then with your mom, you take turns and you cut a piece off. So let's say that you use a little plastic knife and you cut a piece off of this shape like this. Your mom has to take this shape and get the exact same amount of Play-Doh off this shape by just making one cut. So you can weigh it to see if it's the exact same, or you can take the two pieces. So let's say your mom cuts off this much and she says, well, it's fatter or taller, so I better not take as much off. Then you can take your piece, mom's piece, and you can roll them in a ball. Whoops. My Play-Doh's getting old. I need to make some more. But you can roll them in a ball and see, how did we do? Actually, I didn't do too bad, did I? But you could weigh them to find out for sure how close you were to the same size. And then we talked about what shapes were easy to get the same size, what shapes were hard to get the same size. Was it easier or harder than we thought? And that was kind of our discussion that started us off on slicing things and realizing if the shape's not constant, then the slices, the thickness of the slices can't necessarily be the same. It's kind of intuitive when you're just playing a game, but it's still hard to do. Does that make sense?
Okay, no, it does. And we look forward to seeing the video, the recording of it too.
I have 3 recordings to get uploaded and each one takes an hour. So by Monday, it'll be up, but I'll post this one first. So hopefully it'll be up today. And yeah, but if you have a question, you're welcome to email. So parents, I will send you an email right now that has all 11 Sparks in one PDF file that's yours to have and use and play and remix and do whatever you want to be inspired with calculus at your house. All right? Thank you, everyone. Arjun, do you want to say something before we go?
Bye.
Bye. You just keep being good at maths. Goodbye, everyone. And have fun with math. You're all good at math.
Goodbye.
Bye.
Really?
Have a great day.
Bye.
Bye, Violet. Bye, Joe. Bye, Lewis and Jamie. Bye, Crystal. Bye, Lawrence. Bye, Zahabi. Have a great day. Play with math.